Okay, a nice simple demonstration of the boundary effect would be to measure the frequency response of a loudspeaker in free field without any reflections at all, and then we can compare its frequency response when we do place it near some boundaries. We've looked at the theory, and hopefully you're getting a sense of how much of an impact that has on the output of the speaker. So what is frequency response anyway? Well, it's the amplitude measured over frequency. So in other words, we're going to put a sine sweep through from 20 hertz up to 20 kilohertz, and we're just going to measure the amplitude of that signal using a microphone. This microphone is not designed for recording. It's an omnidirectional Behringer mic called an ECM 8000, and it's essentially a super flat response. Wouldn't necessarily sound good on an instrument, but it's designed just for calibration of equipment and that kind of thing. So that's all running into the software. I've actually set the SPL already. The sound pressure level is at a safe level. I've measured it at 80 dB C. We're going to keep the microphone at a consistent distance of 30 centimeters from the center point between the woofer and tweeter, and that needs to be consistent because, as we've seen from inverse square law, any small changes here can have a big impact on the output, so we want to keep that consistent. So I'm going to come with me. We're going to go and have a look at the software. Okay, this is called Room EQ Wizard. It's actually free software. I'm going to just make sure I've got the right input. Yeah, that looks good. So I'll just check the levels. This will produce some pink noise. And the output is set at -12 on a digital scale. The input's analog. I make sure I've got enough headroom because we want to make sure it doesn't clip, so that looks okay to me. Okay, I think we're ready to take a measurement. So I press measure. We're going to press start. Beautiful. There's our first result. So I'm just going to label this FF. Now it's not free field because I don't have an anechoic chamber clearly, and you probably realise there's quite a lot of acoustic problems in this room, but we're just going to get a sense. It's a real listening space. It's 40, that looks pretty good. I'm just going to set that. We don't need that low energy. That looks pretty good to me. Now, because it's taking so many measurements, you get a load of detail that's not actually helping. So I'm actually just going to apply what's called smoothing. That looks a bit better. So that's our first result. It's a bit choppy. There's a deviation of around 5 dB. That's the port. It's a tune port in this speaker. But there's a lot of stuff going on here which is due to poor room issues. This is not an acoustically treated room. It's not designed that way. I don't do mixing in here really. Anyway, that's that. So let's have a quick break while I set up the next experiment, and we can just discuss what we're seeing here.